Hello everyone and welcome back to physics class. Today we are going to be learning about free body diagrams, or FBD for short. Now, free body diagrams are a useful tool to help us analyze the forces acting on a particular object at a given time. Most of the time there will be multiple forces acting on an object, and so free body diagrams is a drawing that you need to be able to make to show all the different forces acting on the object and which direction they are in. Let's start off with, how do you draw a free body diagram? Well, the first thing that you do is you figure out from the problem the object that you're looking at. So for instance, let's say that we have a light that is suspended from two cables. And we want to know, what are the forces acting on the lamp? The next thing that I'm going to do is I'm going to draw this lamp as a point, so as a dot over here. This dot represents my lamp. This dot is going to have arrows coming out from the center of it to represent the different forces. So, for instance, this lamp is hanging, meaning that gravity is pulling it down. So I have an arrow drawn out, and gravity is pulling down, so it's straight down. And this is my force of gravity. Now I have two cables here, right here. These cables are exerting a force at an angle. Now, we haven't really talked about forces in cables so much, but these are tension forces. So anytime you have a cable or a rope, there is going to be a tension force. And so we would write that as Ft. Now, because there's two of them, I'm going to label each of them Ft1 and Ft2 respectively, because we don't know if this is the same amount of force on each side. There are no other forces acting on this hanging lamp aside from these three forces. Let's take a look at another example. So let's say that we have a water bottle resting on a table. Kind of looks like a shampoo bottle, but whatever, it's a water bottle. There we go. So we have this water bottle resting on the table here. We want to know, what are the forces acting on this water bottle? Well, I'm going to draw a dot off to the side to represent my water bottle. I know that gravity is acting on this object, so I'm going to draw a force pointing down, and this is my force of gravity. Now, I also have the normal force acting on the bottle. This bottle is not moving, so I want to try to draw my normal force to be in the opposite direction and the same length as this arrow here. I don't have any forces acting in the x-axis. They're only acting in the y-axis for this particular example. So this is my free body diagram. That is it. That is all. Now, let's say that I was going to push on this water bottle going in this direction here. I would have to draw in two more forces. One being the force applied going towards the right, and then because there's movement happening, I'm going to have a friction force, and this is going to be my kinetic friction. I'm assuming that I'm going to be pushing the bottle so that it's moving. So we're going to have some kinetic friction going on here. Now, let's say that we have a soccer ball, and it's being kicked by a person. Now, this person is kicking it at an upwards angle like this here, so it's going to arc up, and we understand projectile motion, so we know that it's going to fly up into the air and then land a certain distance away from the player. I want you to pause the video for a moment and try to draw out the free body diagram at this point of contact, when the soccer player is hitting the ball with their foot. All right, welcome back. Let's go ahead and draw our free body diagram in this case. So I'm going to draw my dot to represent the ball. I'm going to start off with the force that always is acting on objects on Earth, and that is the force of gravity, and that is pulling straight down. Now, this is still on the ground, so I technically have a normal force acting on the ball as well. And I have this force that's being applied to the ball at an upwards angle. So my force applied is going to be up at this kind of angle here. So this would be like theta, let's say. We also have to consider that there's friction happening in this case. So in this case, the friction would be between these two surfaces here. So our friction is going to happen on the x-axis only in this particular instance. I'm going to be drawing my kinetic friction force towards the left because our movement is towards the right. Even if it's a little bit up, it's still towards the right. So my kinetic friction force is to the left. Hope you enjoyed this video, and I will see you next time when we start talking about the resultant force.